Hello, welcome back to my channel. Today I'm going to talk about a microservice and what are the frameworks used to implement the microservice. One of them I considered as a Spring Boot. Let's understand the components of the Spring Boot microservice based implementation and Spring Web components and simple use case. I would request you to watch from beginning to the ending so that you can able to understand the entire concept associated with the real-time hands-on code exercise. Thank you. Let's jump into the next slide to understand what is a microservice. So you know that we were building applications in olden days as well. There is nothing different in terms of the application building. Okay, that means whenever you say you are having a order management application, so what happens? A person has to raise an order request, specific product to be selected, and then you provide the payment details, validate the payment details, and then you confirm the order request. If that order request fulfilled, they will deduct certain amount as per the product which you selected. And all these things accomplished using a single application. To manage and maintain, say that order has been requesting. During the request time, say that there is no stock of inventory of that particular product. It is difficult to manage in the legacy way. That means all the code put together in a single EAR, jar, or web archive or enterprise archive. These are the different standards used from the Java standpoint of view. I am considering in this particular use case. Okay, so say that if you wanted to manage a payment related activities, it is hard to decouple. If I want to see inventory related, that is also hard to decouple because every time I had to do a redeployment whenever I make the changes because everything put together in a single archive file, either web archive or enterprise archive or jar archive, whatever form of the application development which we are considering. So in the olden days, there was also a REST based web services implemented that we can call it as web services implemented using SOAP based approach. SOAP means Simple Access Object Protocol, which follows a standard called WSDL, Web Services Description Language. Somebody hosts a web service, and then there will be a consumer who can go ahead and consume that service. So they use a contract. Consumer and publisher have a contract definition defined. SOAP follows SOAP header, SOAP body, like they segregated the overall SOAP message. We call it as SOAP envelope. That was based on the SOA architect style, service oriented architect style, but that has more security. But the thing is, it was a very complex way to develop, implement, and deploy, redeploy these things. That's the reason they have used the similar concept of SOA, service oriented architecture. They come up with microservice concept. Microservice concept is basically a similar set of information belonging to one of the application fulfillment. It is being used and develop that piece of application. For example, order management application, as I said, payment service. So you can have payment service separately. You can have inventory service separately. You can have order service separately, so that these are three services. You can have three different small units of applications which can be easily manageable, deployable. That is what the agenda is. So that is what here I have represented. What is a microservice? An application will be decoupled into collection of smaller, loosely coupled services. You don't put all the things into one application. You separate out each responsibility with respect to that feature so that it is easy to manage from the development standpoint of your deployment standpoint of. So microservice, again, as I said, it is following an architectural style, that is SUA, where it has been derived. There are many advantages which I have depicted in the PowerPoint. Hope you can see. Organized around business capabilities. Whatever the features belonging to similar sets can be make it as a one of the microservice. This is this is going to be very rapid rather than the legacy way of development. And we are using microservices. So these microservices, quickly you can production grade features implement and deliver to the customer. These services are fine grained. Whenever you want to make any change without much risks with respect to the application, you can do say that you have one of the microservices running, you wanted to have one more feature on top of it. Definitely you can do a versioning, and you can deploy that versioning, and you can expose that versioning service to your end client. That means you are not interrupting existing production services, but you can able to enhance to fulfill the service. That is how the fine grained can be achieved. And the protocols here, we were using earlier days, as I said, so protocol. Now it is purely based on the HTTP. HTTP is usually a lightweight and stateless, so ensure that you enable endpoint securities and SSL enabled so that the data can be secured between client and server. And also code is highly maintainable and testable. This is another advantage which you get it when you go with the microservice. And as I said, also you can independently deploy. So these are the additional advantages. Who are all supporting? So Spring now it is part of VMware, because VMware they purchased the Spring framework and Spring softwares, and Spark, and Oracle also developing JAX-RS. So that also can use and implement a microservice. So HTTP verbs, you all know that these are all like a REST based operations you can perform. Get, put, post, delete, and so forth. There are different types of HTTP based operations you can build an application. Okay. So in my exercise, I'm going to talk about a simple microservice, which is a web application where I'm going to have a user creation, getting the user by ID, getting the list of users, which is available in the data store, which is in memory data store, and get and expose through a REST endpoint. So here I have used the Spring Boot microservice implementation based approach for building microservices, and by default, I'm using the embedded Tomcat engine for the Spring Boot application. So we know that the MVC architecture, that you have model view controller. So we will see in the next slide, and we will see what is a web. Web is basically you can have an application which can host it within your organization, business to business or business to enterprise or business to consumer, like completely exposing your service over the web, so that your clients can also communicate. For example, www.google.com. So you go ahead and set something, it is hosted from the Google, then request process, blah blah blah, internally it serves and then gets the result back to us. So likewise, you have the applications. For example, here I have depicted today the environment is very much dynamic, and lot of application hosting on the web online. So like if you're ordering laptops, food, shoes, whatever home decor items, everything is going into an e-commerce platform. There are vendors who is supporting buying and selling the things from the e-commerce. So different types of applications within the organization where we can host business to business or business to enterprise, business to consumer likewise. Okay, so here in this particular case, by default, as I said, Tomcat is embedded in engine. We use it. If you don't want, you can definitely change it. So rest full form is a representational state transfer. So this is the simple, MVC architecture. Usually you get, it is all implemented based on the servlet based approach. So you get an input request as an whatever the form, either it is a post form or a get form or a put form, whatever the form which is, and it receives by a dispatcher servlet, that is a front controller, which is underlying used by the Spring implementation, and that request will be delegating to a controller. Basically, the controller is basically how the REST endpoint exposed to the outside world, and then it calls the respective service layer, or service layer makes calls to the database layer and then fulfills your need and then returns the model and view object, and this model and view object will be used and gives back to the controller, that is the front controller will be given to the rest template. You can have it, the rest template, so which can send back to the view template. View template is basically a HTML page or JSP page. How do you construct depends on it. And then finally the response given to the end customer. So this is all about the, you can see that dispatcher servlet is a front controller and controller is a, another, implementation approach where you support get put such kind of operations. So Spring Boot comes with the two types of stacks. One is a proactive stack, the other one is a reactive stack. I hope I have already demonstrated a reactive based application, what are the benefits and how it can be used. And today I'm going to talk about a proactive framework. Proactive, you can see the right hand side. It is purely based on these servlet stack. MVC is built on the servlet API and uses a synchronous blocking protocol. That means whenever you make a call, it makes a block uh, to fulfill your request. This is the implementation underneath we have to follow when we are going with the Spring reactive model, and it uses one per request per thread model. So every request one thread will have. In case of reactive, you can see many threads can span for your request fulfillment. And here servlet containers can be used, and servlet API, Spring Security, Spring MVC, Spring Data repositories supporting the proactive stack. So we are talking today proactive stack. So there are Spring Security wherein you want to securely handle. Definitely you can have OAuth 2 or Keycloak or whatever services hosting. Right now I am not demonstrating all those things because certain things are out of our control locally to do it. So these are the depends on the libraries available we can use based on our needs. So as I said, the web component has been divided into server side and as well as the client side. So server side, whenever I wanted to build a microservice using Spring Boot. So Spring Boot by default, it comes with a Spring Boot application as a auto-wired component. So what happens, this Spring Boot application auto-wired component, which is used to enable three sets of sub-components. So one is a configuration, whatever the class you specify at the rate configuration. So that class will be loaded automatically. And enable auto configuration. This is a default auto configuration. Spring container uses and loads lots of default objects to make it available when starting up of the web container. So if you want to exclude some of those, yes, definitely you can go ahead and exclude it. And component scan, what is component scan? Component scan is basically you have a package, say that com.narayana. This is the baseline package where I'm going to write a Spring Boot applications For example, say Spring Web Application.java, where I specify @Spring Boot application. Whatever the baseline package which I have my Spring Boot application, it starts loading from that package underneath whatever packages are there. It will not load any package, say that I have com.basati, another package. There are two packages, for example, com.narayana, com.basati. So the components which will scan from com.narayana, because my Spring Boot application written underneath com.narayana. It never loads com.basati in case if I have a package. So in case if you want to load even those packages, what you're supposed to do is you can use component scan and specify which baseline package also to be considered to load. You can definitely use this. So that is the beautiful thing which they're given for us. And then server side web and REST components. So as I said, application context, it is a, it is the bean context at the web level, which can be used to load all the web related default beans and whatever the beans which we are specifying from our application standpoint of view. Those things will be placed into the Spring application context bean container. And controller, as I said, we have two types of inheritance. One is a controller, the other one is a REST controller to build the REST API. This the REST controller which will enable to do the request response bodies which will enable it. And also in the olden days we have model and view, these objects which is used to fulfill the data and give it to the JSP template. And now some of the people stopped using those. So because of that, these are also available, but still we are not using it. And client side component. Say I have a REST endpoint which is up and running. Now I wanted to make a call and see my REST client is working and behaving as expected. I need to write a client. So they have provided a REST template. This will be deprecated and will be sooner or later will be removed. Instead of this, they supported to use web client. Please refer Spring Web Reactive video, which will tell how to use the Spring Web client rather than the REST template. Here I am covering the REST template. So this is our simple use case integration. So I have a web layer which is running on the Spring Boot microservice, and I have a simple service layer, stereotype of which is a service instance. And then the database layer which I have is in memory level. That means I'm storing some content in memory, and then when I bring up my server, it will be available whatever if I store it. Whatever which I can able to look up, yes, I can do lookup. If I kill my server, the contents will be erased. That's how simply we can able to test it. We can test either web-based browser or client-based Java or Postman. These are different clients where we can use and test this application. So so as I said, the prerequisites kindly go through. I am using in this particular exercise Spring Boot 3x. This is mandatorily expects Java 17. Without that, this will not work. And to dependency download, you need internet connection. Whatever the exercise which I'm all talking about, these are applicable for the Java developers who had experience on the web development, so that they can improvise their knowledge and the real time, the low level details of the Spring Boot implementations. So that is the intended audience. Uh, whoever would like to learn, please feel free to learn. So these are the helpful links which are available, and my source code is available in the Git repository, Spring Boot Git. You can definitely go ahead. Thanks for understanding the basic concepts. Now let's jump into the real-time hands-on and code how we can understand. Okay, so that is the intended video for this course. Thanks. Hi, as I said, so code is available in the GitHub. Definitely, you can go ahead and check out and You can also test it. Hope you can see that I have a readme file as well. So here I have four endpoints. One is the my REST endpoint home page, what is going to get my home page, and I can post some data to store at the in-memory level, and then I can retrieve by that identifier which I stored it. And I have one more endpoint which is getting the list of users available in the in-memory. This is the use case. So as I was talking that here I have the baseline package com.narayana. Underneath, if you look at it, I have two types of sub packages. One is client package, one is the server side package. First, let's understand the server side package. So this is the package which contains all the server related code. This is the package which talks about the client code. As I was telling, now this is the baseline package. com.narayana.server is the baseline package where I have Spring Boot application which I specified as a stereotype, the annotated or your auto-wired configuration. Okay, so these are called stereotypes according to the Spring terminology. So what that means, whatever the packages underneath server which all will load. Say if I wanted to have another package in the com.narayana. Say some common package. If I want to load, I have to specify here at the rate component scan specify com.narayana.com common if I have a common package underneath the same hierarchy of client, server, and common. So that is how Spring Boot enables. Otherwise, that package cannot be auto loaded. So only it loads underneath the server. Okay. So this is my web application, a simple boot service which is using Tomcat engine. And now I am going to talk about a user controller which is talking about the four REST endpoints. So as I was telling, I have to use the stereotype REST controller or controller I can use. So here I have another object reference that is a service which is, let's see later, user service. I'm defining a constructor user controller and then I'm initializing the user service instance. Here I am using two types of syntaxes. You can clearly watch it. Request mapping. If I am going with the request mapping, I get couple of advantages. I can specify the my path request path and path variable if I want to test my REST endpoint. Here I can specify request methods, whatever I wanted. So that is a beautiful thing which is supporting request mapping. And in this particular case, I have specified get and produces as a JSON as an output. And this is the name of my signature, and I'm getting the integer ID, and then I'm making use of the service call. So this service call is making it to check whether this user is available in the another object that is a map store which is internally using. So let's go ahead and see what is a map store. Now I'm going through the map store and here I'm seeing that map.data structure. That means if there is any data it will retrieve for me, and if there is no data it will not give me any data, it will give me blank. Okay, so this is how this endpoint and getting list of users which is in the in-memory side, and as well as here if you look at it, uh, adding a user, getting user by ID, get list of users. Okay, so that is how this database layer has been designed. I have a database model object which is for a record type, user integer ID and username. So let me first start my web application. Right click on this file, Spring Boot web application. This is going to start. It is going to use a resources file. This is a Spring Web App is the name, and this is the basic context of the application of my microservice. So this is a very simple application which I have enabled. Now you can see that server started in 6.405 seconds. That means my server is ready. I can go ahead and use my server. So now what I can do is, as I said in the README file, I have four sort of URLs. Let me try to look up what contains. So now I can see that blank. That means nothing I have stored as of now, but my service is up and running. As I said, without storing by our side, we cannot get any data, right? So now I have REST client. I'm using REST template based approach. So I am specifying what is the URL where my REST is available. So here I'm specifying adding a user, and I have specified the post operation. So I need HTTP post operation. What is my body? This is my body. For example, say I have 100. Say I'm specifying this is my name. This is the actual body I'm preparing for the post operation. I'm using headers because what type of data which I'm submitting to my server. So that defines, because if you look at the controller, so here I'm saying that what is the data which I can consume as a JSON value and produce as a JSON value. If it is a REST client, if it is a REST corresponding type we have, we can convert the JSON to object format. That's what we are doing here. So I'm adding a content type header and the JSON which I'm submitting, and the body, that is the message which I'm sending for the post, and I'm using REST client. If you see the REST client, this is a REST template as I said before. So REST template I have created, and I am using exchange operation which expects four operations, four parameters. One is the URL which I wanted to call, and what type of method to call, and entity which is a headers which is basically formulated, and what is the return type which I can typecast, so which gives me a response entity which is of return type of exchange. So I am specifying response data, and I am specifying whether the service status success or not I wanted to evaluate. Then I can print some content on the console. So I'm checking whether HTTP status success 200. If yes, then I can print, otherwise I ignore it. I can formulate it with something else based on. I'm not covering here errors, exceptions, blah blah blah. Those are not the intention of this video session, please. Okay, and here I'm printing something: user added success, response data get body. Let's try this. Now my server is up and running. What I can do is I can go ahead and start my REST client. So this REST client, I have written everything in the main body, so it is going to make a call to the server. So it is saying that add user success. Now it is saying that you can see clearly that the user has been added and the identifier is 100 and the username is Narayana Bassetti. Now let's go ahead and refresh the previously requested. Now I can see that yes, there is a data arrived. So as I said, I can use either Postman or REST client. In this particular exercise, I'm using the REST client, which is based on the REST template. Now let me add another user. For example, say Narayana. Only this I'm going to add it. Again, I'm rerunning my REST client. So let me see whether it is added or not. Yeah, we got the message saying that it's available. We ensure that whether it is added or not, because I'm making a call to. Now I can see that username Narayana, this is again added to my in-memory store. Now let me go ahead and find based on the user ID. By get user by ID. So I am specifying a path variable. So 100 I will be considered as an input, and then it will go and call. Now I am able to get it, right? So this is all about this use case. If I want to see my home page, yes, definitely I have here. Welcome back, Narayana University. This is my home context of my application, the microservice application. So I hope this will give you immense understanding of the Spring Boot. What are the components internally it is used? Thanks for watching. Please try to watch from start to end so that you understand concept followed by the real time. You will not miss anything. Uh, Please subscribe, share it, like it, comment it. I'm happy to try to rectify if I have a faults at my side, and hope I come up with new video with new concept. Thank you.